In this video, we are going to take notes on the laws of exponents. So make sure you have a nice full page in your notebook, and we are going to title this Laws of Exponents. And then we're going to make a table. So in our table, we're going to have one column for our example and another column for the rule. So let's go ahead and start out with one of the ones we were doing yesterday, or one like we were doing yesterday, where we had, let's say, x to the 5th times x to the 3rd. And I want you to write down, based on what you learned yesterday, the patterns that you noticed. What would that equal? Remind yourself why that was. Do it now. Okay, hopefully you said x to the 8th, because if we wrote it out, we would have 5 x's written out and then 3 x's written out, all of them multiplied together, meaning you have 8 x's multiplied together total. So now we're going to try and generalize this. So let's say we have x to the power of a times x to the power of b. I want you to write down what rule would you follow to multiply those together to simplify. All right, and hopefully you're writing x to the power of a plus b. So next we looked at what happens when you divide, or when you have a fraction. So let's say we have x to the 5th over x to the 3rd. We saw how if you wrote this out, you would end up with 5 x's multiplying on the top, 3 x's multiplying on the bottom, and 3 of them would cancel from both top and bottom, leaving you with just x squared. So let's write that out with algebra. Let's say we have x to the a times x to the b. What's the pattern? What always happens? Write it down now. All right, hopefully you have x to the a minus b. Okay, now let's look at what happens when you have the power of a power. So let's say we have x to the 3rd to the power of 5. So we remember that means what we're doing here is 5 groups of x to the 3rd. And of course, if once we write it out that way, then we can see that by using our rule from up here, that would just give us x to the 15th. So let's go ahead and write that with algebra. So x to the a to the power of b. How did we get that 15? What did we do? All right, hopefully you see that what we did there is x to the a times b. Okay, now we're going to leave room for 2 more rules here. We're going to come back to them in a minute. But in the meantime, we're going to do something a little bit different. And this is going to give us a pattern for how to figure out when you have 0 as an exponent or when you have a negative number as an exponent. So I'm going to switch to a new page. You may just want to do this underneath. Well, I guess, yeah, you can just do it underneath what we've done. Take those notes. So let's say what happens when you have a variable to the power of 0. No matter what that variable is, this is always going to equal 1. So for the rule, let's just write it out with words. Anything to the power of 0 equals 1. Some of you may have heard that before. We will have plenty of time to see some other reasons why that's true and to think about that more. Next, let's think about a negative exponent. So let's say x to the negative 3. The pattern I tried to show you would show us that that equals 1 over x to the 3rd. Once again, this is a big idea. It's weird. At this point, I'm mostly asking you to just accept this, and we'll spend some more time in the next couple days thinking about why this is true and how we can use it and why it has to be that way for math not to break. So then our general rule here would be that x to the negative a is going to equal 1 over x to the a. The other way to say that is that if you have a fraction a over b and you're taking it to the power of negative 1, that's going to take the reciprocal of that fraction. It's going to flip it. So make sure you have those rules written down, and we will talk about them more, I promise. For today, what I want you to do is you are going to be matching some cards that have some different exponential expressions on them. You will have to use negatives. You will have to use power of 0 in there. And then once you have them matched, then you're going to go ahead and play a game of memory with your partner. Hopefully you played that game before when you were a kid, where you turn all the cards face down and then turn over matches one by one to try and get a match. When you have one, you can keep it, and then you get to take another turn. All right, back in class tomorrow. Good luck. So we're going to call this how do 0 and negative exponents work. And we're going to be using powers of 2 for our example. So we're going to make a nice long list. We're going to start with 2 to the power of 4. And I want you to write underneath that number, what is 2 to the power of 4? I'm going to do the same thing for 2 to the power of 3, 2 to the power of 2, etc. Okay, so we know that 2 to the power of 4 is 16, because that's 2 times 2 times 2 times 2, 4, 8, 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. Now at this point I want to back up a step, and I want us to look just at the numbers that we just wrote down. So as we go from 16 to 8 and then 8 to 4, what's happening? How can we predict the next number in the pattern just by looking at these ones, not by thinking about the exponents? Pause for a moment, talk to your neighbor, tell them what you see. All right, hopefully you're noticing that each time it goes, we are dividing by 2. So then we can continue that pattern of dividing by 2 and see if that holds for the next one. And 2 to the power of 1, that would be 2, so that works. Now, if we follow that pattern, what would that make the next number? Fill it in now. So if we're dividing by 2, 2 divided by 2 should give us 1. 2 divided by 2 equals 1. Now, that maybe feels okay. That tells us that 2 to the power of 0 equals 1. Well, let's continue one more step. And if we continue doing this, if we continue dividing by 2, now, well, 1 divided by 2, that would give us 0.5. Or I'm going to say it as 1/2. We divide by 2 again. That gives us 1/4. Or 1 over 2 squared. And 2 to the negative 3, that would be 1/8. Or, more importantly, 1 over 2 to the third. All right, you may want to pause here, talk about this, see if this makes sense. If you have questions, try and talk about it with your team, and then go back and we're going to fill out the last 2 rows in our notes based on what we just discovered. All right, so I know this is a big idea. We are definitely going to be talking about this more, but for right now, we are going to go